Hi, everybody. So I want to give you some examples of work done by constant force and work done by variable force. So let's start first with this example right here, this pen. If I want to lift this pen up off the desk, the only thing that how hard it is to do that is dependent on is the mass of the pen, the acceleration due to gravity, and how high I want to lift it. All those things together would form the work that it would require to lift this pen. So, like the mass of the pen doesn't change as I lift it. Neither does the acceleration due to gravity. According to Galileo's experiment, it stays the same no matter how high I want to lift it, no matter what it is that I'm lifting. So I would take that mass and multiply it by 9.8 meters per second squared, and that would give me the force on this pen, okay? And it does not change. It remains constant as I lift it. So I just take that force and multiply it by how high I want to lift it, and that would give me the calculation for the work done in lifting the pen. Now, not always does the force remain constant. Here's the first example that we're going to look at, which is with Hooke's law. With Hooke's law, the more we try to displace a spring from natural, the harder it is to displace it, the harder it is to do that work. So the force varies with actually the displacement. By Hooke's law, it's proportional. The force is proportional to the displacement. Another example, this spring is coming from a trampoline, so it's not too bad, not too hard to stretch from natural. But a spring that's really hard to compress from natural is those giant springs that are on cars that are used for suspension, right? So the greater the force, or the greater the distance that you want to displace or compress in that case, the suspension spring, the harder it is to compress, the harder the force is required, according to the spring constant that is for that suspension spring. An example of constant force work would be lifting this glass of water a certain amount of a certain length. Right? If I'm lifting that glass of water, the only thing that depends on is how much the glass of water weighs and how much I'm lifting it. Multiply those two things together and I would get the work done for lifting this glass. But what if the glass had a leak in the bottom of it? If it had a leak in the bottom of it, then as I lifted it, the mass of what I'm lifting, the weight of what I'm lifting would be changing. And so that would cause me to have variable force. So I'd have to figure out like how much force is required to lift it just this little bit and multiply it by that little bit, how much to lift it by this just little bit and multiply it by that little bit, and how much to lift it by this little bit and multiply it by that little bit, and add all those together to get how much to lift the whole thing. Because each time I'm lifting it, I have less in the glass because of the leak. So multiplying those things together and adding them all up, infinitely many of them would calculate the work. But if we're doing the limit of a sum, what we're talking about is integrating. And that's what where the calculus comes in. One more example of work done by variable force is right here, Wilson's rope. Wilson's rope is coiled on the floor here, and it's a pretty hard, heavy rope, okay? So if I go to try to lift it off the ground, when I lift the first little bit, it's maybe not that bad, but the more I lift, the more I have to lift, which means that until it comes up off the ground, my force is increasing with how much I have lifted or how the distance.